And lastly, specific heat. All of this phase change discussion was really to get us to this one property of water. Specific heat is the amount of heat needed to raise the temperature of something by 1 degree Celsius. Every substance has a specific heat. Okay? Okay. Somebody tell me in your own words what specific heat is. So, right here, it is the amount, let's see, this is 50 degrees C, and this is 51 degrees C. It is the amount of energy that the system absorbs right there. So, water is made up of 2 hydrogen atoms and 1 oxygen atom. The oxygen atom's the fat one. The hydrogen atoms are the little ones. When we talked about periodic trends on the periodic table, one of the things that we talked about is that you can tell what relative size something is going to be based on where it is on the periodic table. Remember me saying about uranium and zirconium fitting in the same crystal lattice together? Please tell me I talked about this.
Yeah.
Okay. Well, oxygen is way over here, so it is a much bigger atom than hydrogen over here. Hydrogen has 1 lonely proton and 1 lonely electron, whereas oxygen is over here, and it's got, well, its atomic mass is 16, so it's got a bunch of protons and neutrons. 8 protons and 8 neutrons. Okay, so it's big relative to hydrogen, so that's why it looks like this. Now, the other thing that you can tell by looking at the periodic table, I'm pretty sure this film is actually not seeing me, so I'm over here. One of the other things you can learn by looking at the periodic table is that the farther to the left on the periodic table an element is, the more it really wants to give away its electrons. Because it's only got 1 electron in its outer shell. It's easy to lose 1 electron. It's harder to get 8, or in hydrogen's case, it doesn't need 8, but all the other elements on the left-hand side need a whole bunch of electrons to be happy. So rather than gain a bunch, they just lose 1, and hydrogen is one that follows that same rule. You can make hydrogen gain 1. It's not very happy that way. Whereas oxygen is on the opposite end of the periodic table. It likes to gain electrons because it's easier to gain a couple than it is to lose 6. Does that make sense? Okay. Again, oxygen wants to gain an electron. Hydrogen likes to lose electrons. So this positive and this negative, now they're sharing. So what you have is you've got hydrogen with 1 electron. You've got oxygen with 1, 2, 3, 4, 5, 6 electrons. Okay? You've got another hydrogen here with 1 electron. So what they do is this hydrogen and oxygen share these 2 electrons. And this hydrogen and this oxygen share these 2 electrons. Okay? So because they're sharing and not just giving each other away, they don't become ions. So oxygen doesn't get a whole charge from hydrogen and become completely negative and flow off by itself. It's sharing, so it's hanging out close to hydrogen. But since oxygen likes to have more electrons, it's more electronegative is the term, but you don't have to know that term yet. It's got a slight negative charge, just a little bit of a negative charge, and the hydrogen has a little bit of a positive charge because it's sharing its electron, but it's sharing it more. So the electron might spin twice around oxygen before it goes and wraps around hydrogen once, for example. The electron spends more time with the oxygen, so the oxygen's a little bit more negative than the hydrogen. Does that make a little bit of sense?